Welcome to Easy Peasy Math for Amateur Radio by David Okrent, W7DAO, copyright 2024, all rights reserved. Many people taking their first amateur radio course and licensing exam worry about being able to do the math. Often there's a belief that they will be called upon to remember some long forgotten or never learned math skills like algebra. However, the fact is, for most amateur radio, all you need is addition, subtraction, multiplication, division, and the ability to press the calculator buttons to raise to a power of 2 or take the square root. In other words, all the math is easily done with paper and or a calculator. Does this mean there's no algebra involved? Yes, there's algebra, but the method you're going to learn now hides it from you. This will take you to the equations you need quickly and painlessly. What you're about to learn has been taught to electronics technicians since at least the Second World War. This is a tried and true method. What we're going to focus on is how to manipulate linear equations without using algebra. But first, let's take a little digression before we dig in. When people are taught math, often they aren't told what it really is. No one withheld this information from you. It just got lost in the shuffle somewhere. What is math? It's a language for describing the workings of the world around us. It's the language of physics, the prose of relationships between elements. The manipulation of equations and their parts is like working with words, grammar, and sentence structure. When you see math in this context, you can better see the beauty and elegance of our universe. Let's start and dig in a little bit to this. First, a quick review of the order of operations, and that is how we're going to evaluate an expression. We have a very specific set of conventions, so everybody's working the equation the same way. And you probably remember this from elementary school or middle school or high school. First, we're going to evaluate what's enclosed by the parentheses first. After we've done that, we're going to do any exponents or roots next. A square root is basically raising a number to a power of a half. Multiplication and division are done next, and neither takes priority, and the convention is to process from left to right. Then we do the additions and subtractions, and again, these don't have any priority. The convention is to process these from left to right as well. And so these are the rules that we all follow when we evaluate an expression, so we end up with the same answer. What is a linear equation, though? Linear equation is in this kind of form: a equals b times c, or x equals y times c, whatever the variables are. There can be more than 3 variables. There can be a number of them, but the key thing is that they do not have any exponents or square roots involved in them. They are basically a equals b times c, very simple math, and you will not see things like a equals b squared times c to the cube, the cube root of c. You won't see that in a linear equation. And because you have an equal sign, what's on the left must equal the right. You can also write this equation in the opposite direction, where the expression is on the left side and what becomes the result is on the right side. Both of these expressions are exactly the same and interchangeable. So how do we solve for y in a problem below? So what is y? Given that x equals y times z, if x equals 345, and z equals 24.3. Well, we can start by doing the algebra. So we need to solve for y. We start with that equation, x equals y times z. And remember, what we know about this is what's ever done on the left has to be done to the right to maintain the equality. So first we're going to multiply through by 1 over z. So on the left side, we're going to get the result of 1 times x is x, z times 1 is z, and so we're going to get a result of x over z, which equals to the right side expression. And here we're going to see that the z's will cancel out. Z divided by z is 1. And by that equation, we'll end up getting x over z equals y times 1 over 1. And we know that 1 over 1 is 1, so x over z is equal to y times 1. With the resulting equation is y equals x over z, or y equals x divided by z. Both equations are equivalent. We use that line like a fraction to indicate division as well. Now we can just plug in the numbers and we can get an answer like y equals 14.2. Now that is pretty straightforward. It's not complex algebra, but there are a number of steps to be taken, and sometimes we can drop a sign or forget to do something and cause an error in our reduction of the equation, simplification. So what we know is there is an easier way. Why? Because it's been taught, like I said, since at least World War II. And so get a piece of paper and a pencil and draw a circle. Step one, easy peasy. Step two, we're going to draw a horizontal diameter line down the center. That gives us two buckets, two sections of the circle. Next, we're going to draw a vertical radius line at the center of that horizontal line to create three containers, three sections on the circle. Once we have these three sections, we can take those three variables and map them to each section. Whatever is on the left of the equal sign goes to the top box, and whatever is on the right of the equal sign goes to the two lower boxes. It doesn't actually matter which order the y and z in. It could be zy or yz. It doesn't matter as long as they're put in the lower boxes. And this is for a three variable problem. Now, what we know about this little strange circle is that anything that is vertical, above and below the horizontal line, is going to be division. Anything left and right of the radius line is going to be multiplication. So x, remember, x divided by y with the division sign is the same as x over y, or written like a fraction. And y times z is the same as y times the quantity z, or yz, because as you may remember from math class, the multiplication is implied when the variables are written in this way. So let's solve for y again. We already know that x equals 345 and z equals 24.3. So let's go find y. Let's draw our circle. Let's put our variables in that circle, x, y, and z. Let's cover the unknown. So the unknown is y. By covering the unknown, we can see that there's x and z, and they are vertical to each other. They're above and below the horizontal line, which indicates division. So the equation is y equals x over z, which, of course, is 14.2 when we plug the numbers in. There was no algebra involved. We just cover the unknown, and the equation appears. So let's walk around the equation. So we already know that if we cover y, we get x over z. But if we cover x, we get x equals y times z. And if we cover z, we get x divided by y. So just by covering the unknown, the equation appears. And many of the formulas in amateur radio can be evaluated with the circle method. Ohm's law, the power law, AC volts to DC equivalency, wavelength and frequency, all of these can be evaluated using the circle method. So let's work a problem, especially with shared variables. The total resistance of, or R, of the circuit is 300 ohms, and you'll learn about some of this later. So some of this language might be unknown to you. And the current, or I, is 1.45 amps, 1.45 amps. What is the total power used? Well, let's look at the power law circle. Well, P equals I times Z is the equation itself. We know we're looking for P, but we need to find I and E, and we know what I is, it's 1.45, but we don't know what E is. However, we do know there's another equation, Ohm's law, which has E is equal to I times R, or E above in the top part of the circle and I and R in the bottom parts. And we don't know what E is, so we need to find it. But we do know that by covering E, that the equation shows us that E is equal to I times R. We do know what I is, we do know what R is, and we then know that, that E is equal to 435 volts. Now we can plug that back in to the lower circle, the one on the left, the original one, and we have 1.45 amps times 435 volts equals 631 watts. So we did this essentially by a process called substitution. And by doing substitution, we can come up with a lot of different equations. Here is the actual substitution we did if we wanted to do it in one step, essentially not doing it as two separate equations, but by looking at the circles and writing one equation, we would have ended up with P equals I squared times R, which is the same, which is a linear equation we separate out as I times R. And you can see we come up with the same answer as we did before. And we can do this for a lot of different combinations using substitution. In fact, it turns out by working with these two circles, we end up with 12 different formulas for solving most of the problems we have with power and voltage, current, and resistance. Now, you can memorize all 12, and people do, Or you can memorize the three circles, and when you need a formula, you can then use substitution or a simple to come up with one of the formulas from scratch. All depends on what you're comfortable with. And for most people, there it's pretty much split. For me, I don't have to remember things as much if I just have the circles. Again, it's whatever you like to do. You will need a calculator, of course, to do the square roots. Of course, I can say like any other commercial, but wait, there's more. We can take this to another level of complexity, and we can look at something a little bit more complex, capacitive reactance, which is a formula that we use or a concept we have in electronics. Again, we're not going to talk about that right now. Where x of c, that's the capacitive reactance symbol, is equal to 1 over 2 pi the frequency times the capacitance. And we can do some algebra here where we end up, again, what's on one side has to equal the other side. We're going to multiply through by 2 pi fc to get rid of the fraction, so to speak. And we're going to be able to cancel that on one side, and then we're going to end up with the equation where 1 equals x of c, capacitive reactance, times 2 pi times frequency times capacitance. Again, some of these terms may not mean anything to you right now. That's okay, just so you understand how this works. Well, now it's not a circle. We're using a rectangle. We put the 1 on the top, and now we have 2 pi, which is a constant, which you can replace with 6.28. We have the frequency in hertz, we have the capacitance in farads, and x of c in ohms. Again, some of this right now may not mean a lot to you, but just look at the form. And because we have this form, we can now do calculations as we did before. What is capacitance given F is equal to 28 million hertz and X of C is 2,584 ohms? So we start by finding the equation, cover the C box, and by covering the C box we get C equals 1 divided by the quantity 6.28 times the frequency times X of C. And here is that equation written out. And we're going to get a really, really large number on the bottom. So how do we deal with that? Well, whenever we do 1 divided by something, we're actually taking the inverse of that large number. And so all you have to do is put that number into your calculator and either do 1 divided by that large number if you want, or push the inverse key that many calculators have. And by pushing that key, you will then be able to get to 2.2 times 10 to the minus 12, or what you'll find out later is 2.2 picofarads. And so that is how we solve that equation. We did not have to do any algebra but cover the unknown. So we can also do another problem. What is the frequency given that we have X of C, again the same amount of ohms, 2,584, and a capacitance of 0.00000000022 farads, okay, which we know is going to be 2.2 picofarads, 10 to the minus 12. Cover the F to get the equation. F equals 1 over the quantity 6.28 times the capacitance times the capacitive reactance. We then evaluate that expression, get a very, very small number in the denominator, which whenever you divide by a very small number, you get a much larger number. So again, we can go to the calculator and either take 1 divided by that small number or take the inverse of that number with the inverse key and get, in this case, 28 megahertz. And that's how we solved that problem. Again, we didn't use algebra, we just covered the unknown and got the equation. And this also works for inductive reactance. If you look at it here, it's much more like our x equals y times z. And so although we have an extra box for the constant, it is essentially the 3-element problem we've had before. So now you know the secret of the circle, how we make math for amateur radio easy peasy, how we manipulate linear equations without using any algebra. So I hope you found this worthwhile. And if you have any feedback, please feel free to provide it to w7dao@arrl.net. Thank you for listening.